Yeah, so I primarily, and pretty much now all I do is work with mass timber, and I've been doing that for probably close to 10 years now, which has been kind of an interesting sort of journey. My background is sort of structures and somewhat structural timber, and then the fire side of timber, and then have done a lot of work over the years on light timber frame, glulam buildings, old historic buildings, anything related to timber really. But certainly in the last, I suppose, 15 or so years, as more and more buildings have started to use glulam and then into CLT, and at larger and larger heights, and I suppose more and more complicated buildings, they've needed people like myself who understand how the fire interacts with the structure and have wanted to look at different solutions, innovative solutions. And so I've been, in some ways, quite fortunate to be able to be involved in quite a range of projects in all different countries as well, from Europe, Canada, US, Australia, countries in Asia. And it's been interesting to be able to see how mass timber has grown from the point of view of the number of projects and the spread of it, the extent of projects that are going on now, I think, which is incredible, and then just the innovation as well, to be able to continually see how we're taking a very traditional project and turning 4x2s and 4x6s, or sorry, 2x6s into something which is tall and doing some amazing things structurally. So yeah, it's really interesting, and it's my role has just been part of that process.
Yeah, we're lucky to have you on because not many people have had exposure to all the codes, and there seem to be different approaches around the world, but it seems to be underlying in the same sort of physics. I mean, fire's fire, and at the end of the day, timber's timber. So from your perspective, what are sort of the, looking at risk, is my novice understanding, it's all, risk is probably the fundamental thing we're trying to address. So how do you approach that from a fire point of view, and what are the risks from your perspective?
Yeah, well, I think go back to how you started that. I think the codes are kind of crazy in some ways, and trying to explain it to anybody is difficult. Even people in codes don't understand generally how codes are kind of coming out. And there's this constant theme you hear in code committee meetings about the whole sausage factory, that you never want to be involved in it and see what's going on because it's a pretty messy process. And I think the positive part is that codes continually are changing and wanting to adopt mass timber, and that's driven by the desire for more sustainable buildings which aren't so carbon intensive, and there's governments are making that change. And the issue is that in some ways codes are historic documents. People innovate in buildings, and then codes kind of catch up, and some catch up very slowly and others catch up quite quickly. And so you see this continual change going on as we continue to innovate with mass timber, and it's going relatively quickly. And so some countries, codes are a long way behind, and other countries they're actually right up there, in some ways a little bit more advanced. And so I think that's really important for everyone to understand, as well as that. And I see this all the time, as you see architects and developers looking on architectural websites and seeing a timber building and saying, I want one of those, and it's kind of like, yeah, but your code says you kind of can't. You're stuck at kind of 4 stories, and you can't have 18 stories, and it's a big challenge to be able to overcome that. And I think that's really important, because it goes to that aspect of fire risk and life safety risk for people, because the codes set the underlying, I suppose, level of performance. And it's the same for all buildings, whether it's a 6-story office building constructed of concrete, or a 20-story apartment building constructed of steel or concrete or timber. There's an underlying level of fire safety and performance, and different countries address that in different ways. Some put sprinklers into buildings, some rely on compartmentation, others have both compartmentation and sprinklers, and there's history behind those. And we've got to also understand that fire risk is also very different in relation to the approach to aspects like how people evacuate, how firefighters attend the fires. And so the structure of a timber building has to fit within the prevailing nature of the codes and the regulations and standards that are there, because they've been around for a long time. And then we bring this relatively new technology in some ways, and in some ways it's not so new nowadays, depending on the market you're in. And then what we're doing is we're challenging the code to say we want to build taller and larger buildings with the same material. And so it's a question then, how does it fit within that risk? And so in some ways, long answer to get around to the point that I think the codes are really important because that sets the performance level. And then sometimes, in some ways, like an 8-story timber building, which sounds kind of not that exciting, an 8-story office building, which you can kind of think you can build anywhere, could be very, very acceptable and very easy to build in one location, and very, very difficult to build in another location for exactly the same building. And as you say, the timber's the same, the fire's the same, the people are the same, all the systems that go into it are relatively the same, but that level of risk changes, and that perceives the way that the building has to be treated. And so that's a challenge for us. It's a challenge for developers, owners, engineers, everybody to be part of that.
Yeah. Yeah, I'll drill down a bit further, and this is just coming from a place of curiosity because I see and there might be some, underlying frustration from a personal point of view because it seems to be the same physics, but like the International Building Code seems to be quite far progressed forward, and I totally get we don't want to be moving too fast at the risk of unknown unknowns. And then, relative to Australia, it's like there's a big step change, it seems, in allowance for exposed timber. And I guess the devil's advocate of if we play, we got to make sure that the sustainability and biophilia credentials is balanced against that sort of, if it is in encapsulation strategy. So, I mean, what are Australia relative to the rest of the world? What do you think we're sitting right now?
I mean, I'll answer it two ways. First of all, personally, I think you've got, kind of high-rise buildings and low and medium-rise buildings. And typically there's a line somewhere in the sand in most codes of where you get to high-rise. Some it's, perfectly delineated. In Australia, it's 25 metres. We kind of have very different requirements above and below 25 metres. In other countries like the US, the IBC, it's 26 metres, it's 85 feet. And you have different, criteria, and a lot of countries are like that. And for me, low and medium rise buildings, the buildings that were sort of that 6 and 7 story floors, I think, 1 hour fire rating, 60-minute fire rating, put sprinklers in them, leave all the timber exposed, perfectly okay. I think there is no issue at all with buildings like that. And I think we should be exposing the timber, and we should be having codes that allow lots of buildings like that to be built, because that's the strength of timber, is low and medium rise buildings. We want to have all those kind of boring 3 and 4 story office parks built out of timber. That's where the change is going to occur, to have, the sustainable buildings we really want. It's in that 2, 3, 4, 5 story range, and all those kind of unexciting kind of buildings. That's where the change has to happen. And then for buildings, and I think, in some ways, that's where Australia should be as well. We should be having those buildings, fully exposed timber, have sprinklers in them, and you can just, pretty much you can have a whole lot of basic standard solutions. Architects can download all the typical details. Engineers can, easy to price, easy to build, go straight through from a permitting point of view. It's not a trouble, easy to price, easy to build, very competitive. And that's kind of where we want it to be. Anything that's kind of high rise, and there's a different requirement from a code perspective, because it's more about how do you design the building to allow it to withstand a very extreme fire and still stay up structurally? You need more engineering, you need more analysis, you need more research to go into a high-rise building. And that's where encapsulation becomes part of the storyline. How much timber you expose becomes important, the type of building, how tall it is, a whole lot of other issues, how protected are the stairs, pressurization. There's a range of different fire safety measures that go into a high-rise building. I think we should be able to delineate between taller buildings and having greater fire protection. A lot of it, the type of work we need to put into those buildings from an engineering and approval point of view, as opposed to low and medium-rise buildings, where we can make them, very simple to build and have a product which is desirable for the engineering, construction, and architecture and developer community to want, and becomes a very competitive, building against, concrete and steel, because that's what we want. I mean, I'm an advocate of mass timber. I want our buildings to be a lot more carbon positive, and we've got to have, codes and standards that back that up. And that's where I think the change needs to occur.
Yeah. And you mentioned, 25 metres Australia, I think you said 26 metres the IBC. What is sort of that step change? What is the big difference there that goes from low to medium and in terms of risk, it's a big step up in terms of when we go to high rise.
Yeah, and one of the, I suppose there is a number of items that go with that from a fire point of view, and part of it is that, you know, high-rise building is, you know, a 10-story building is a high-rise building, but an 80-story building is a high-rise building, and they're very different. And but from a code perspective, they're not actually that different. And so that's part of the issue is we typically don't, some codes actually have a stepped process where you can kind of step through different heights and you sort of gradually make a change in types of fire protection. Certain codes just have a kind of a clear line, and it's, you know, there's very, you know, there's maybe a couple of smaller changes, but realistically it's a bit of a line in the sand. And that kind of, when you talk to people who are outside of that, they kind of, well, it doesn't make sense. Why is a 10-story building the same as an 80-story building? But that's the reality of what we face, and that's the history, and that's fine. Just deal with that. But part of that is the structure itself. So if we have a high-rise building, we have to design the structure on the basis that even though it's got automatic detection, automatic sprinkler systems within it, we have to assume that those systems fail to operate correctly. And then we have to assume that the fire brigade actually are quite delayed or potentially fully delayed in actually fighting the fire. So the structure has to kind of stand on its own 2 feet. So we have to ensure that a fire that occurs, which is a pretty extreme fire, can grow and burn itself out, and the structure still stands. And that's quite a significant goal for any building, whether it's concrete or steel or timber or any sort of material. You've got to go through a process of making sure that your high-rise building is a very, very resilient structure. And from a timber perspective, that's quite a challenge, simply because we haven't done, you know, internationally that many high-rise buildings. We've had to go through that process and looked at exposing the timber. And I think that's the issue. You can, you know, Brock Commons building in British Columbia, you know, it was a very early tall building, 18 stories. You know, the decision was made to, you know, wrap all that with fire-rated board on the basis of, you know, getting around that issue. And that was exactly the right decision to make, to allow a building like that to be built. And there's others which have been like that, where it's made sense to kind of encapsulate or wrap some or most of the timber. So now there is a lot of push to be able to say, well, let's try and expose some of that. And I think we've got to be sure of the research that we've got with that, which we've got some really useful amount of research on that, but also be aware of the limitations of that as well, and what it does tell us and what it doesn't. And I think that's part of the important part, going back to your questions about fire risk, about knowing what we do know, and then knowing where the gaps are and where the limitations are, and being able to design taller timber buildings within those. And, that's the important part now and in the future as we continue to research this and continue to look at building those sort of buildings.
Yeah. Yeah, no doubt in this question you could probably go on for 3 days, but there's a lot of nuances in fire design. I'm aware there's a lot of research. What do you see as some of the most fundamentally important research and addressing some of the nuances that we need to find out from, say, those hopefully now known unknowns, which were previously maybe unknown unknowns?
Yeah, I think, for me, and I think importantly is when you have a lot of exposed timber is that the fire that burns from all the materials, which and all the furnishings and fixtures, everything which sit in the space, the timber actually interacts with the fire, and so you've got the fire interacting with the timber. But if the timber is exposed, that timber and the burning of that timber will actually interact with the fire and change the fire, and that doesn't happen with the steel and concrete structure. And so that adds another level of complexity, which means that all the methods and correlations we used to have, or we currently have for steel and concrete buildings, don't work and shouldn't be used for timber buildings. So we've got to amend those, change those, or have new ones. And so the way we can analyze, spaces with exposed timber has to be different. And then part of that is we've done quite a lot of research looking at, in some ways, smaller compartments, so like residential type compartments. So, sort of 50, 60, 70 sort of square meters up to sort of 100 square meters of a residential space, and had some really, really good research showing how the fires develop in those, and understanding how the ventilation in the windows and the type of fuel and the type of materials, the type of CLT and glulam can burn within those spaces. And that's really, really helpful. So we've got some really good information on residential spaces. What we don't have is really good information on large spaces and large compartments. And we have methods and methodologies for large open spaces where we've got steel and concrete, and we have method to be able to understand how the fires burn within those. But that doesn't apply and isn't really valid where we've got the timber, because the timber changes the fire. And so that's the area where we need to do more work on. And it's important, I think, for us to be able to understand the limitations of what we know in those large spaces where we do have the timber exposed, because it changes the fire, it changes the way the fire sort of grows through the space, and also the way it comes out of the windows, which is important because that's potentially important for sort of vertical fire spread, and it also changes the way we think about the way that the actual structure interacts with the fire, especially things like timber columns are really important as well. So, there's continue to be good research, but there's also some gaps. And so that's where, from our point of view, we're being very cautious about how we design taller buildings with large open spaces with timber being exposed. I think they're the area of the biggest unknown at the moment.
Gotcha. So on that, so you got a, so to speak, traveling fire then, because there are some buildings I'm aware of that has partial encapsulation. So how would you sort of position encapsulation or something like that to help mitigate this sort of risk?
Yeah, and it's an interesting approach, because I think there's a certain amount of, part of it is a certain amount of analysis that you can do, but there's a certain amount of analysis you can't do, because you don't actually know what the kind of what the right answer is, because you can, some ways, if you can imagine, all the analysis we do is typically based off some form of testing. And so the analysis has always been, we've done a certain range of tests, and we know that within that sort of envelope of tests, we can carry out sort of analysis and be confident with it. And then if you go outside that, you've got to be a little bit more conservative, or do a lot more work to be able to make sure you're getting the right answer. When it comes to the type of exposure and where the exposure is against where it's encapsulated, there is a lot less on that. And so, we've got the ability to understand how that may influence the fire, but we've also got to have the ability to understand where that may have some detrimental effects on the fire. And a good example of that is that, in some ways, a lot of architects would want, if you said to them you could have half the timber exposed, say on the ceiling, or say the CLT, most architects say they'd want it near the windows, because when people are outside the buildings, they can look into the building and see the timber. And generally, when in some ways, there's a lot of sort of meeting rooms and other kind of unexciting spaces around the centre of the building. And so, you want people to see the timber as they walk towards the windows. And so that all makes sense. The issue from our point of view is that if you have the exposed timber near the windows, it actually increases the flame heights, which would extend if you have a really, really extreme fire, which basically means you're spreading the fire relatively, potentially quicker. So from a fire point of view, you actually want it the other way around. You'd rather have the timber away from the windows and potentially have that as and take away that influencing factor. So there are aspects like that which we know about, but we need to understand how that's going to work in a building, and also be able to work out whether that's actually going to stack up for the building as well, because in some ways you've got to be able to balance what's reasonable architecturally and cost-wise, but also balance what's going to work from an engineering point of view.
Yeah. I'm interested to get your perspective, and I think there's some disagreement in industry who I speak to on this, and that's around dealing with structural adequacy. So, how you deal with the char rate and what your capacity is of the panel. There's probably one school of thought where you need in Australia, AS 1530 Part 4 tests and do a fire test for everything and leave it all to the testing authorities. And then you got the other school of thought, leaving it more of a performance-based design and maybe passing on a char rates to a structural engineer, maybe using the STEP model and, the proper char models that are around the world. What's your perspective on that? Is it something for, say, testing laboratories to be making the call, or is it something in the scope of a structural engineer with assistance for the fire engineer to treat adequacy?
Well, I suppose from my point of view, all the methods of calculation methods are derived from testing. So you've got to have the testing to be able to then have a methodology you can use from a calculation point of view. So, we prove the methods are appropriate based on, the testing that's been carried out, and pretty straightforward from that. And that's no different to any other material that, typically you either test a lot, and then at some point so people sit in a committee and decide that we've tested enough and we can actually publish something which can be used by engineers, and then we don't have to do so much testing, which is exactly the right approach. And we always want to be able to do that because testing is relatively expensive, and we want to be able to make sure that buildings are cheaper and efficient to be able to build. So from my point of view, and this is where it comes back to, if you've got codes and standards that support a certain type of building, which allow you to build very easily without having to do any analysis and without having to get people like me involved, you can just basically pick a whole lot of straight details off and you've got a code compliant building. That's where we want to go. I don't, people like me should be doing ourselves out of a job. I don't want to be involved in the design of timber buildings from that point of view. They should be easy to build without getting engineers involved from the point of view of having to do performance-based analysis. We should be able to say, here's the code, here's some standards, you tick all these boxes, you do a standard design like you would for steel and concrete, and then you can build your 6-story office building, and someone can price it, get it built, and it's very straightforward. That's where we should be, and that's where we want to be. And then if it's different, if it's complicated, if it's tall, if it's crazy design or whatever, you need to do something different because it's not what's in the code. You get engineers involved, and you do a whole lot of analysis, and that's where you need to do something a little bit different. So from my point of view, I think I don't think in some ways we've done enough testing of CLT and glulam that we shouldn't need to do any more testing of the material, unless it's someone who's got something new or innovative or doing something slightly different, which I think we still need to. There's ideas of doing a lot of low-grade combination CLT, which I think is really positive. There's people doing all sorts of different size of different timbers with CLT to see how, and it's all about how do we use more of the tree in engineered timber, which is great. All those things slightly innovative, need to do more testing to see if they meet the current correlations, but for a standard design, we shouldn't need to do that. We shouldn't need to test. We should be able to have basic, simple methods to be able to engineer it, and we shouldn't need to have any sort of performance-based design unless it's a complicated building, a tall building, something a bit different. And that's where we should be working towards, and that's where I hope we could get towards.
Yeah, the answer might be my question here a little bit, but like, so if I'm an architect or builder right now and I don't want to reinvent the wheel, what does it say the best path to go down that they know they're going to get the most simple sort of design and compliance pathway to make sure and de-risk the need for fire testing at all and the costs and program risk that might come along with something like that?
Yeah, and I think it's being as compliant as possible with appropriate codes and standards. There is a pathway to build a 6-story office building now within the code, but it means that you've got to put on a layer of plasterboard on the timber, but you don't need the fire test. And I think in pretty much most countries where unless you're countries, there's some countries who still you're stuck at 3 or 4 stories for timber buildings, but anywhere you're slightly taller, there is always a code path to be able to build a timber building. And my philosophy in most projects is that we want to be able to make it as easy to approve as possible. And so you want to be able to go down the path which is the path of least resistance, because the best timber building is one that's actually built rather than the ones which are designed and priced and then don't get built. They're not good, and there's a lot of those unfortunately which don't get built. So we want to be able to make them easy to price, easy to build, but also of course easy to approve. So the easiest path is you've got there's fire tested CLT out there. There's an appropriate standard to assess the timber from a showering point of view. We've got all the tools you need to be able to build a timber building at the moment up to 25 metres of most classes. Office and residential are going to probably be the predominant ones, but obviously assembly buildings, libraries, whatever, you could do that now. It's just a question that if you're going to step outside the code, that's when you need people like myself and others to be involved, and you need a certain level of performance-based engineering and performance solutions to be able to get you around whatever part of the code you're not meeting. And that's where the level of complexity jumps up, and that's where it becomes more expensive, it becomes timely to get it approved, and you've got to go through that process. So to me, if we can, and I do this, I say to people, why don't you just build it to the code? You'll get a building which will be so much simpler to be able to get approved and get built, rather than have to go down this path. And it's potentially going to be a lot longer to approve. It's peer review, there's potentially appeals or whatever to be able to do that. And it's a difficult process, and that's not what we want for timber buildings. That's, kind of goes back to we've got to change things so we allow the easy, simple, medium and low-rise buildings to be built in a way which makes them easy to build.
Yeah. Fantastic. Well, it's been so good speaking to you, David. I'll end on a pretty open question for you. It can be on this topic or anything you like. What do you see as the future of timber construction going forward 5-10 years, and with a bit of blue sky thinking?
Well, I would hope. Certainly, I hope we can build more timber buildings. That's the first thing, and I would like them to become more efficient, and I think they will be. And I think if you look at sort of North America as a market, the US and Canada, and then you look at sort of Europe as a whole as a market. Codes are changing to support mass timber. There is more production, which has been really important from a timber supply point of view. And as in some ways, it seems to supply, demand and supply for timber can't keep up. The more we supply, the more the demand grows. And that's really, I think, important. And it is kind of one global market for timber supply. And that's, I think, something which is really interesting, because it means we see a certain amount of competition, but also a lot of situations where the timber is a lot easier to be able to source than maybe it was 5 or 10, more than 10 years ago. So I would like to see the barriers being removed and continually being removed, that allows us to build more and more buildings that are the normal buildings, but also sort of 8 to 10, 12 stories. I think we could certainly get to a point where we should be in Australia, New Zealand, but also parts of Asia, and hopefully in Europe it's starting to move this way as well, where maybe it's sort of 10 or 12 stories is a line in the sand, where you can build a timber building. You put in these fire protection measures. You don't need to put a whole lot of in some ways not so carbon friendly materials on the outside of a timber and protect it all. And those buildings are easy to build and efficient, and that's the change we want to have to be able to lower the carbon impact that we have with buildings at the moment. So that's where I'd like it to see it to be. And I hope that we will get there. But it does mean changes to regulations and codes. And I think the market is willing to support that. And I can see that will actually happen. So, yeah, it's important for people like me and others to continue to try and help influence and get codes and regulations changed.
Fantastic. Well, it's been so good speaking to you today, David. If people want to find out more about yourself and some of the research you've been up to, where should everybody go? Feel free to, drop you or myself a line. Just email me. It's fine. David.barber@arup.com. People do it all the time. My email address isn't too hard to find. So, or just, drop me a line on LinkedIn or something. I'm always happy to help out and answer questions if I can, or point people into the direction of people who can. So there's a lot of good timber people out there who can provide, I think, good support, and certainly from a timber industry point of view, there's a lot of I think goodwill of people wanting to be able to make sure that timber buildings can get started, and if they've got problems, to try and get around those. So yeah, absolutely, feel free to reach out. Fantastic. I also recommend listeners, I think you've got a few on YouTube, which I might have seen before when I was just jumping on the exercise bike and wanted to watch something a bit nerdy, but there's a few webinars, I believe, from yourself. So thanks so much for coming on the show, David. It's been a pleasure to be able to speak to you. Yeah, thanks very much, Adam. And great to talk with you.